Okay, so this is another section to the simplifying radical expressions. So radical numbers can also be divided. We looked at multiplying them in the last video. So you group the coefficients just like you did with the multiplication, and then you also group the radicals so that you can divide. So you kind of separate the two if you have them, and then you divide the pieces. So if possible after that, then you would take the square root of the radical that resulted from the division. So in this case, there are no coefficients. There's no numbers in front of the square root of 2 or the square root of 72. It's a 1 technically there, but we're not worried about ones. So if there were numbers in front, you would divide those, just like you normally would as far as reducing them. But now we have 2 and we have 72, so I can divide both of these by 2. 2 can divide by 2, 72 can divide by 2, right? So 2 divided by 2, I get 1. And then 72 divided by 2, I get 36, okay? And if you notice the square root symbol is gone because 2 divided by 2 gives me 1, and the square root of 1 is 1. Now, I probably should have left this here because I'm also going to do the bottom one here because now I have 36. So again, if you recognize your square roots, this makes it super easy because I know the square root of 36 is 6. So really, I should still have the square root sign here so that I can get rid of both of them at the same time there. So just something I will go back and fix here after the video. So on this one, if the fraction is simplified with a radical in the denominator, then it must be rationalized. So in this case, there is nothing for me to do as far as the division goes. It's 2 divided by the square root of 2. Well, I can't actually do 2 divided by 2. One's a constant number and one is a radical number. They cannot be divided. They're not like terms, okay? So to rationalize a fraction, the numerator and the denominator are multiplied by the radical in the denominator. So think of it kind of like improper and proper fractions a little bit. Like we're basically just making it proper, okay? It's just fixing it so that we don't have the radical in the denominator. So I'm going to take that square root of 2, and I'm going to multiply by the bottom and the top, the denominator and the numerator, okay? So 2 times the square root of 2, well, that's just 2 square root 2. If you have a square root times itself, if they're exactly the same, so square root of 2 times square root of 2, it actually gets rid of the square root sign and it's just 2. And we can think about why on that one, because 2 times 2 is 4, and the square root of 4 is 2. So if you're multiplying a radical by itself, you're going to end up with a square. And you can just take the square root of that number, which is going to be the number you're multiplying by. So now I can simplify a little bit more, and I can go 2 divided by 2 because these are now both numbers. This number is being multiplied by the square root of 2, but that's okay. They're not radicals. So I can reduce this, and I could just have the square root of 2 here, since it would be 1. So I can definitely reduce this a little farther, although it looks like Alex may have let me stop because I didn't put it on the PowerPoint. It looks like Alex may have let me stop at this point. But sometimes it will make you finish reducing, and sometimes it will let you go to this point. So just kind of keep in mind that there are a little bit of quirks with the system on that sometimes with how far they expect you to go on the simplification. So this was simplifying radical expressions with division. So I hope that helped, and I'll see you in the next video.